Welcome back, and today we're going to get into special forms. In this particular video, we're going to look at factoring two-term polynomials, binomials, but they fall into these special forms known as the difference of squares, the difference of cubes, and the sum of cubes. So let's start off with the difference of two squares. There's not a method that's really behind factoring these. There are actually formulas that exist that give us the factored form of these particular binomials. So for the difference of two squares, the general formula, if we have any binomial of the form a squared minus b squared, that's equal to the factored form of a plus b times a minus b. So the first thing that we want to look at here and make sure that we have is that both of our terms are perfect square terms and that we're taking the difference between the two. So let's take a look at a couple of examples. For our first example, we're going to take a look at x squared minus 81. First thing we see is that both of these terms are in fact perfect squares. X squared is just x squared. And 81, we can write that as 9 squared. In this instance, just using our formula, the a will represent x, b will represent 9. Substitute the x and 9 for a and b in the formula, and so we have the factored form x plus 9 times x minus 9. And that's it. No AC method, no pairing off of terms, just following the formula. Let's look at a couple more examples. This example, we have 9z squared minus 25. Once again, both of these terms are perfect squares. 9z squared we can write as 3z quantity squared, and 25 is simply 5 squared. Now it's a good idea to express these as some quantity squared because that tells you what your a and b are going to be when you apply the formula. So following the formula once again, we have 3z plus 5 times 3z minus 5. For our next example, we have p squared plus 9. Now here, we do have perfect squares, p squared, and 9, that's 3 squared. The problem here is that this is plus. In this instance, this is not factorable. The formula that we use requires a difference of two squares. The difference of two squares we can factor. The sum of two squares is not factorable. It's not factorable over the real numbers. If you see a sum, if they're perfect squares but you're adding them together, it's prime, it's not factorable. So you want to keep that in mind because the temptation might be to just go ahead and follow through with the formula, but it's not going to work there. And all of these can be confirmed by simply taking your answers and multiplying them out and seeing if you come up with the original problem. For our last example here, we're going to look at 16y to the fourth minus 1. So once again, we want to express these as squares. So 16y to the fourth, well, that's 4y squared, quantity squared. And 1, of course, is its own square. So we can write that as 1 squared. So following the formula here, this will give us 4y squared plus 1 times 4y squared minus 1. Now at this point, you might be inclined to think that you're done. However, look at that second factor. 4y squared minus 1 is also the difference of two squares. 4y squared is 2y quantity squared, and 1 is still a perfect square, 1 squared. Is we can apply the difference of two squared formula for that expression as well. So if we do that for that case, that's going to be 2y plus 1 times 2y minus 1. Now, this alludes to something else that's important to note when it comes to factoring. When we did the formula the first time, we got 4y squared plus 1, 4y squared minus 1. Now, that was factored correctly If we were to multiply that out, we would still get 16y to the fourth minus 1. However, it isn't factored completely. There may be instances where you may be able to do further factoring of the expressions or the factors that you have. And so you always want to double check what you have for your answers to see if you can go any further. Now, we'll address that in the last video when we go over a general strategy for factoring. If we have the difference of two cubes and the sum of two cubes, just like the difference of two squares, there's no real factoring method that we have to go through, but there are specific formulas that we have to apply. Here we have the formulas on the board. So for a cubed minus b cubed, the formula is a minus b times a squared plus ab plus b squared. For the sum of two cubes, a cubed plus b cubed, that's equal to a plus b times a squared minus ab plus b squared. So notice that the formulas are similar and they have slight differences in the signs, particularly in the binomial part of it and in the first term or the first or between the first and second terms of the trinomial part of the formula. Once again, let's look at a couple of examples. So let's start with x cubed minus 27. Once again, we can see these will be the difference of two cubes. So the x cubed, that's just x, quantity cubed. And then 27 is 3 cubed. So if we look at the difference of two cubes formula, a becomes x, b becomes 3. So we'll have a minus b, or in this case, x minus 3 times, and then we have a squared, so that's going to be x squared plus a times b, or x times 3, plus b squared, or 3 squared. All right, so just using the formula straight here, this is the result that we get. Now, we got to clean this up. So the trinomial part, we can clean that up. So that'll give us x minus 3 times x squared plus 3x plus 9. So now you might be wondering, the trinomial part there, x squared plus 3x plus 9, is that factorable? Well, in this case, no. And 99% of the time, that trinomial part, when we apply the formula for the difference or sum of two cubes, will not be factorable. So you typically don't have to worry about doing anything about that one. So we can just leave the answer as is. For our next example, let's take a look at 8a cubed plus 125. First of all, recognize both of these terms are perfect cubes. 8a cubed, well, that's just 2a quantity raised to the third power. And 125 is 5 raised to the third power. All right, so our a and b in this case are going to be 2a and 5. So now if we apply the formula, this is the sum of two cubes, so we start off with a plus b. So in this case, that'll be 2a plus 5. And we multiply that by a squared. So this will be 2a. I'm going to put that in parentheses because the whole thing is going to be squared there. 2a squared minus a times b. So that's 2a times 5 plus b squared, or 5 squared. So when we clean up here, we have 2a plus 5 times, now 2a squared, that's going to be 4a squared, minus 2a times 5 is 10a, plus 5 squared, which is equal to 25. And so that's going to be the factored form here. What we can see here is that both of these forms are fairly straightforward in how you work them out. There's no technique or method that's applied here. You're just applying the formula. Now, we have to be careful that we apply the formula correctly when we're doing these and make sure that your terms do fit the formulas correctly. So if you're applying the difference of two cubes, make sure that both of your terms are perfect cubes. Make sure that you are looking at a difference. If it's the sum of two cubes, same thing. Both terms need to be perfect cubes. If it's the difference of two squares, make sure that both of the terms are perfect squares. And if it's the sum of two squares, you do nothing because the sum of two squares is not factorable. I hope this was helpful. Thanks for watching the video. If you have any questions, you can leave them in the comments below. Please consider liking and subscribing if you like these videos. And once again, if there are other videos or other topics you'd like me to cover, I'd be more than happy to go over them. Just leave those in the comments as well. You guys have a good day and see you later.